BYD, short for Build Your Dreams, originally started as a battery company in 1995. Fast forward to today, BYD has stormed past Tesla to become the #1 EV manufacturer on the planet. So, is BYD having the last laugh? The CEO of one of the biggest giants in the electric vehicle industry has just announced the launch of all-solid-state batteries. BYD had already changed the game with the introduction of the BYD Blade battery, known for its incredible capability of charging a car in just 10 minutes. While this may sound like science fiction, it's actually the next big leap in EV technology. With an incredible range and lightning-fast charging, BYD is rewriting the rules of what's possible for sustainable transportation. But what does this mean for the future of electric vehicles, and how will it impact drivers around the world? Before diving into why BYD is making this huge switch, it's important to understand what all-solid-state batteries are. Most batteries today, like those in phones, laptops, and electric cars, are lithium-ion batteries that use a liquid electrolyte to move energy around inside. However, these liquids can be dangerous if the battery overheats, sometimes catching fire or exploding. All solid-state batteries replace the liquid with a solid material, eliminating the fire risk and making the batteries safer and more efficient. BYD decided to switch to all solid-state batteries because of these major advantages. Manufacturing these batteries requires extremely controlled conditions and remains labor-intensive compared to traditional lithium batteries. But the benefits are worth it. All solid-state batteries not only improve safety but also boost energy density, allowing cars to drive much longer distances on a single charge, sometimes hundreds of miles, and recharge in as little as 10 minutes. This makes EVs much more practical for everyday use and long trips, reducing range anxiety for drivers. Beyond EVs, these batteries can also benefit drones, smartphones, and renewable energy systems, helping to create a more sustainable energy future by storing and distributing power more efficiently. BYD's move to all-solid-state batteries reflects its commitment to innovation, sustainability, and leadership in the EV industry. By improving safety, performance, and practicality, BYD hopes to encourage more people to switch from gasoline-powered vehicles to EVs, supporting global efforts to reduce carbon emissions and combat climate change. However, despite their incredible advantages, all solid-state batteries also face challenges. One of the biggest obstacles is cost. Producing these batteries is significantly more expensive than manufacturing standard lithium-ion batteries, and the required materials like solid electrolytes are costly and not as readily available. Additionally, specialized equipment and processes make mass production more difficult. While the future of all solid-state batteries is promising, overcoming these challenges will be crucial for their widespread adoption. The high costs needed to produce all solid-state batteries on a large scale add to the overall expense, making it difficult for manufacturers to offer them at competitive prices. Reducing these costs is a major focus for researchers and industry experts who are exploring alternative materials and production methods. Another huge challenge is scaling up production, as most all-solid-state batteries are currently made in research labs or small production facilities. While producing a few prototypes is manageable, manufacturing these batteries in large quantities for global markets presents logistical and technical difficulties. Scaling up requires building new factories and refining production techniques to ensure consistent quality. And until these hurdles are overcome, the availability of all solid-state batteries will remain limited. Durability over time is another concern. Although these batteries are known for high energy density, they can degrade with repeated use. Tiny cracks can form in the solid electrolyte during charge and discharge cycles, reducing performance and energy transfer efficiency. Researchers are actively working to create more durable materials to withstand repeated use. Internal resistance is also a technical problem, as solid electrolytes can struggle to maintain a seamless connection with the battery's electrodes, affecting efficiency. Scientists are experimenting with new designs and materials to improve this interface. Temperature sensitivity presents yet another challenge, with many all-solid-state batteries performing best at higher temperatures, making them less reliable in cold climates, a major drawback for electric vehicles that need to perform consistently across all weather conditions. Engineers are working to develop batteries that operate effectively across a wide temperature range, but this often involves working at high pressures and temperatures, increasing manufacturing costs. Additionally, public and market acceptance is a concern. Although the benefits of all solid-state batteries are clear to experts, businesses and consumers may hesitate due to the high cost, questions about reliability, and unfamiliarity with the technology. Companies will need to prove the long-term advantages, like reduced maintenance and improved safety, to build trust and encourage adoption. Despite these challenges, BYD remains committed to innovation and is incorporating all solid-state batteries into its ecosystem. This move could significantly enhance BYD's legacy of innovation. Known for constantly improving its products and promoting environmental sustainability, BYD sees all solid-state batteries as a transformative technology. They offer a safer alternative to traditional lithium-ion batteries, addressing major concerns like overheating and fire risks. BYD had already improved battery safety with the Blade battery, but all solid-state technology takes it even further by replacing liquid electrolytes with solid materials, nearly eliminating the risk of short circuits and thermal runaway. This is crucial for electric vehicles, where safety is a top priority for both consumers and regulators. Additionally, all solid-state batteries offer higher energy density, perfectly aligning with BYD's focus on efficient energy solutions. These batteries can store more energy in the same space compared to traditional options, potentially enabling vehicles to achieve ranges exceeding 600 miles, a significant leap over current lithium-ion batteries. By adopting this concerns about range anxiety, BYD continues to reinforce its position, but longer ranges as a made possible by all sustainable transportation are making electric energy solutions more practical and appealing. This helps BYD attract more customers and encourages a shift from gasoline-powered cars to EVs. No company currently makes or sells more electric vehicles than BYD. But there's more. In addition to longer ranges, all solid-state batteries enable much faster charging times. Charging an electric vehicle, which can currently take several hours, becomes much more convenient with all solid-state batteries, sometimes requiring as little as 10 minutes, making the experience comparable to the quick refueling times of traditional gas-powered cars. BYD's commitment to improving the user experience is evident in its adoption of this technology, as it directly addresses one of the biggest barriers to EV adoption. These batteries also contribute to BYD's legacy by making EVs more environmentally friendly. Sustainability has always been central to BYD's mission, and the improved efficiency and durability of all solid-state batteries mean fewer resources are needed to produce and replace them over time. They also have the potential to reduce reliance on harmful materials like cobalt, which carries environmental and ethical concerns related to mining. By exploring sustainable alternatives, BYD minimizes its environmental footprint while leading the industry toward greener practices. The versatility of all solid-state batteries further enhances BYD's innovation. While mainly discussed for EVs, these batteries can also be used for renewable energy storage, storing energy from solar panels and wind turbines more efficiently, and they hold potential for applications in drones, smartphones, and medical equipment. Integrating this technology into multiple sectors allows BYD to expand its influence and continue shaping the future of energy. Furthermore, all solid-state batteries support BYD's commitment to global carbon reduction efforts. As governments worldwide implement stricter emissions regulations, automakers must innovate to comply. BYD, always ahead of the curve, not only meets these regulations but often exceeds them, offering more efficient, reliable, and sustainable vehicles to aid countries in their transition to cleaner energy systems. This commitment fits BYD's broader mission of building a better future through green technology. Finally, the introduction of all solid-state batteries highlights BYD's role as a trendsetter in the industry. By being among the first major companies to adopt this technology, BYD sets an example for others, reinforcing its reputation as an innovation leader. Its success could accelerate industry-wide adoption of all solid-state batteries. As we look at these exciting changes, it's clear we are entering a new era where traditional engines and electric vehicles both offer unique benefits. Advanced engine technologies could one day surpass EVs, combine the convenience of traditional cars with the eco-friendliness we need, while others are convinced EVs are the ultimate future. Which side will you be on? That brings us to the end of this journey. Yet the innovation continues with the rise of Xpeng Motors. The dream of flying cars, once thought to belong only in science fiction, is now becoming reality. China has introduced the world's first functioning flying car, a groundbreaking achievement over 10 years in the making. This marks a huge shift in how we move, live, and think about transportation. No longer trapped in endless traffic, the promise of taking to the skies could change everything. Behind this revolution is XPeng Motors, a company making waves in transportation innovation. Known for its cutting-edge electric vehicles, XPeng Motors leads the charge toward a cleaner, smarter future. The company's latest innovation, the X2, is a battery-powered aircraft known as an eVTOL electric vertical takeoff and landing vehicle, setting a new standard in mobility and technology. XPeng Motors, co-founded in 2014 in Guangzhou, China, by Xiaoping, a former senior executive at Alibaba, Xiaohong, a former senior executive at GAC Group, and other tech entrepreneurs, aim from the start to create smart electric vehicles that are environmentally friendly and packed with cutting-edge technology. With strong backgrounds in technology and business, the founders brought a unique perspective to revolutionizing the automotive industry, blending their passion for cars with tech innovation. Under their leadership, XPeng Motors has evolved into a global player not just in the electric vehicle, EV market, but also in the flying car sector. From the outset, the company focused on making EVs that could compete with traditional gasoline-powered cars, appealing to a broader audience with advanced features, high performance, and stylish designs. XPeng's commitment to innovation is evident in its significant investments in research and development, leading to the launch of its first model, the XPeng G3, in 2018, a smart electric SUV with a large touchscreen, advanced driver assistance systems, and over-the-air software updates. As the company gained traction, it expanded its lineup with models like the XPeng P7, a sleek electric sedan featuring autonomous driving capabilities, smart navigation systems, and large digital displays, further cementing its leadership in the EV sector. XPeng Motors is a pioneer in autonomous driving technology, offering advanced driver assistance systems that utilize cameras, sensors, and AI for features like adaptive cruise control, lane keeping assist, and automatic emergency braking, while their vehicles can also receive continuous software updates remotely. As XPeng grew, it expanded internationally, entering markets in Europe, started with Norway in 2020, and eyeing the U.S. market with plans to introduce models like the P7, G9, and G6 to global consumers. Beyond electric vehicles, XPeng has ventured into flying cars through its subsidiary XPeng Aero HT, developing the XPeng X2, a groundbreaking flying car combining the convenience of driving with the freedom of flight. The X2, built with VTOL vertical takeoff and landing technology, is compact, environmentally friendly, and designed for urban travel without the need for runways. Measuring 5,172 millimeters in length, 5,124 millimeters in width, 1,362 millimeters in height, with a curb weight of 680 kilograms and a maximum payload of 160 kilograms, the X2 operates more like a large drone than a traditional car. It offers seamless transitions between driving and flying, enabled by advanced electric propulsion, autonomous flying systems, and a user-friendly joystick control, making it accessible even for those without piloting skills. Inside, the X2 features a spacious, high-tech, and comfortable interior with real-time displays for vehicle status, navigation, and altitude, while its construction uses innovative, durable materials. The XPeng X2 represents not only a technological leap forward, but also a significant step towards greener, zero-emission personal transportation. As XPeng Motors continues to innovate and expand globally, it is well-positioned to shape the